So we're going to be developing another method for working with our second order linear differential equations called variation of parameters. And this is going to be, we're going to be learning a process for coming up with the particular solution that we need for a non-homogeneous system. And as part of the method development for this, we need to use Cramer's rule. So you did Cramer's rule in linear algebra. This is just here to remind you about the Cramer's rule technique. So if we had a 2 by 2 system of equations, so two equations in two unknowns x and y, in linear algebra we rewrote this in matrix form as a sub 1, a sub 2, b sub 1, b sub 2 times xy equals c sub 1, c sub 2. And then we usually called this coefficient matrix right here, we usually named it A. So we said A equals a sub 1, a sub 2, and then b sub 1, b sub 2. And then we talked about calculating the determinant of A, which is just the determinant of the coefficient matrix. And when we did Cramer's rule, what we did is identified that if we wanted to find a solution, x and y, or frequently we called it x sub 1 and x sub 2 instead of x and y, but if we wanted to find x and y that solved our system, we could do it using determinants. And the method was to take and calculate the determinant of the coefficient matrix A, and then we would create another matrix, we called it a sub 1. And the way that we created this matrix was we replaced the first column of A with the c sub 1, c sub 2 vector. So we did c sub 1, c sub 2, b sub 1, b sub 2. We calculated this determinant, and then we created another determinant, a sub 2 we usually called it. And then we took and left the first column of the coefficient matrix alone, and we replaced the second column of it with c sub 1, c sub 2. And then we identified that we could find solutions x and y if the solution's unique. In other words, if the determinant of A isn't equal to 0, then we could find a solution A over, gotta do this right, the determinant of A sub 1 over the determinant of A. And a second solution, our solution for y could be found by doing the determinant of A sub 2 over the determinant of A. So this was a way of finding our solution x and y, that ordered pair x and y, using determinants. So we're going to be developing a technique that's going to rely on our using Cramer's rule as part of the solution process.